Imagine soaring across the sky at Mach 1.4, faster than the speed of sound. But instead of the deafening sonic boom that once banned supersonic travel over land, you only hear a soft. That's the future NASA is building with the X-59 Quiet Supersonic Jet, and they've just hit a major milestone, successfully running its F414GE-100 engine at maximum afterburner for the first time. This breakthrough isn't just about speed, it's about rewriting air travel rules. What does this mean for the future of aviation? Let's dive in. The X-59 is an experimental supersonic aircraft built by NASA under the Quesst Mission to revolutionize high-speed air travel. The major challenge? Eliminating the loud sonic boom that has historically restricted supersonic flight over land. A crucial step toward achieving this goal happened on December 12, 2024, when NASA conducted the first maximum afterburner engine test at Lockheed Martin's Skunk Works facility in Palmdale, California. At the heart of the X-59 is its F414GE-100 engine, a modified version of the General Electric F414 used in fighter jets. This engine generates a powerful 22,000 pounds of thrust, allowing the X-59 to cruise at Mach 1.4, 1,074 miles per hour, at 55,000 feet. But to push the aircraft to its limits, NASA had to test the engine's maximum afterburner mode, where additional fuel is injected into the exhaust to produce even greater thrust. The purpose of this test was to validate three critical aspects of the engine's performance: operating within safe temperature limits, high-powered afterburners generate extreme heat, which must be managed efficiently, ensuring stable airflow. At supersonic speeds, airflow must remain steady to prevent engine failure, seamless integration with the X-59's other subsystems, ensuring the engine works in perfect harmony with the aircraft's avionics and aerodynamics. The test confirmed that the engine can handle maximum thrust without overheating, that airflow remains stable, and that all components work in sync. This is a major green light for the program, pushing the X-59 closer to its first flight in 2025. Why is this so important? Without this successful test, the aircraft couldn't move forward to high-power flight tests, taxi tests, and eventually airborne trials. Supersonic flight has always faced one massive hurdle: the sonic boom. When an aircraft breaks the sound barrier, it generates shock waves that merge into a loud, explosive noise, often heard as a double boom. This has led to strict regulations banning supersonic flight over land since the 1970s, limiting aircraft like Concorde to oceanic routes and preventing the widespread adoption of high-speed air travel. The X-59 is designed to change that. Instead of a disruptive boom, it creates a gentle thump by reshaping how air reacts around the aircraft. The key lies in its long, pointed nose and unique fuselage design, which carefully manages shock waves, preventing them from merging into a loud explosion. This low-boom shaping technology is what makes the X-59 so revolutionary. Unlike previous supersonic aircraft, which generated sharp pressure spikes that created the boom, the X-59 distributes these waves more evenly, softening the noise and making supersonic flight acceptable for overland routes. NASA's Quesst mission aims to gather real-world data on how people react to this new supersonic signature. In upcoming test flights, the X-59 will fly over selected U.S. cities, and NASA will survey residents to determine whether they find the sound acceptable. This data will then be handed over to regulators like the FAA and ICAO, potentially paving the way for new laws allowing supersonic flights over land. Another crucial innovation is the X-59's engine placement. Unlike traditional fighter jets, which have engines underneath, the X-59's engine is mounted on top of the fuselage. This placement helps reduce noise reaching the ground and enhances aerodynamics. By directing much of the engine noise upward, away from the surface, the aircraft further minimizes its sound footprint on communities below. This approach is a significant step forward in overcoming the noise pollution concerns that have long hindered supersonic aviation. The maximum afterburner test was vital in ensuring the engine produces enough thrust while maintaining its quiet characteristics. If the engine had failed under extreme conditions, the project's entire premise could have been at risk. But the successful test means that the X-59 is on track to prove that quiet supersonic travel is not just a theory, it's reality in the making. What does all this mean for the future of air travel? If NASA succeeds with the X-59, we could be looking at the return of commercial supersonic flights, but this time over land, not just oceans. Imagine flying from New York to Los Angeles in just 2 hours, or from London to Tokyo in half the current time. This would revolutionize global transportation, making long-distance travel faster, more convenient, and more accessible than ever before. Business travelers, emergency response teams, and international trade operations would see immediate benefits, enabling faster decision-making and enhanced global connectivity. But before that can happen, there are challenges to overcome. Regulatory approval. Even with successful test flights, aviation authorities need solid data before adjusting regulations. The Quesst Mission's community feedback program is essential in proving that quiet supersonic flight is feasible. If NASA can demonstrate that the X-59 produces a low enough noise level to avoid public disturbance, it could lead to new FAA and ICAO policies allowing commercial supersonic flights over populated areas. One of Concorde's biggest downfalls was its high operational costs, expensive maintenance, and limited passenger capacity. To succeed, future supersonic aircraft must be cost-efficient, profitable, and accessible to airlines. Companies like Boom Supersonic and other aerospace startups are already working on smaller, more efficient supersonic jets that could complement NASA's research, bringing a new wave of supersonic airliners to the market. Sustainability. Supersonic jets typically consume more fuel than subsonic aircraft, which raises concerns about carbon emissions and environmental impact. NASA and private aerospace firms will need to explore efficient, eco-friendly propulsion systems to make supersonic travel a viable option in a world focused on reducing aviation's carbon footprint. Advances in biofuels, hybrid electric engines, and hydrogen propulsion could be key to making supersonic travel both fast and environmentally responsible. Another critical factor in making supersonic travel a reality is airport infrastructure. Many modern airports were not designed for frequent supersonic flights, so adaptations in runway length, noise mitigation zones, and air traffic management systems may be needed before widespread commercial use becomes practical. With the successful maximum afterburner test, NASA has taken a huge leap toward redefining the future of air travel. The X-59 isn't just another experimental aircraft. It's a game changer, proving that we can fly faster without the deafening sonic boom that has held back supersonic travel for decades. If the upcoming flight tests go as planned, this could be the beginning of a new era, one where supersonic travel is quiet, efficient, and available to passengers worldwide. The dream of fast overland supersonic flights is closer than ever. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, spaceinews.com. Thank you for watching, and see you next time.